Hey y'all. So I want to continue my discussion on Aristotle's wheel paradox, which is my last video. First of all, I want you to understand that motion is not ambiguous. When they say motion is relative to a frame, that's coming from our perception. Motion is in relation to things, but it's not ambiguous. If it were ambiguous, it would violate the conservation of momentum. Because you could see, like, if you could say that something's moving or it's not moving, then the last thing that it interacted with, it wouldn't have conserved momentum because the momentum is ambiguous. It's not that hard to understand. And also when something's, so it's moving, it's not moving in itself, it's moving towards or away from something. But it's not really even moving towards or away from something through space, it's moving an angle. Like we're talking about how physicists are using this idea of angular velocity. And that's because there's a coordinate system for Earth, radial, theta, and phi. So you got the radius of the Earth, and the theta angle between objects is goes with the spin of the Earth, and then perpendicular to the spin of the Earth is the phi angle. And the coordinate system is not separable from the objects themselves. You can't, we're not moving through a coordinate system. The objects are defining the angle from the, center of mass of the planet. And, each one has a radius. Also, I want you to understand that the Earth is not flat or curved. You're not walking along a surface. There are no surfaces, as we were talking about, because that would be like a three-dimensional circumference. And remember, if you have a circumference, then you're going to have Aristotle's wheel paradox to contend with, and that's not taken into account. And it's a problem for the inverse square law too, because the square is coming from the equation for the surface area. And if there are no surface areas, then what is it? It means something else, right? Gravity is not even a sphere. Well, why is it spherical? Well, it's because gravity doesn't have a preference in the direction in which it contracts, right? So that's why we have a sphere and not a flat Earth. It would actually be more complicated to try and explain like why it would be flat in one direction but not the other, even though it is perturbed by the moon, right? So it is being stretched, or it's oblate too because it's rotating. That's not why it's oblate, but it's associated with it. I'll talk about that someday. But even though gravity is symmetrical in how it contracts, the contraction itself is asymmetrical. It's contracting rather than expanding, right? So that's interesting. And if you've been following this channel, you know that I think that nature can be redescribed as combinations of opposing concepts, like symmetry and asymmetry, or if you want simpler terms like sameness and difference. That also makes it so the fact that gravity is symmetrical in how it contracts, is that fact is not separable from the fact that it contracts. It's like they go together. The asymmetry in the contraction rather than expansion goes with the symmetry in how it contracts. It's like everything has to have opposing concepts like that. Just to give another example that's related, like the rotation of Earth, right? If you take opposite sides, they're moving in opposite directions, right? But they're the same magnitude. So there's a symmetry in the magnitude of rotation, but an asymmetry in the orientation. Like one's going this way and the other side is going the opposite way. So that's interesting. This is different than how science thinks about, say, rotation. They're asking an epistemological question, like how how fast is the Earth rotating? That's what they're really asking. Whereas I want to ask questions like, what is rotation? What is this conceptual composition of rotation?